All right, guys, this is the relearning video for Unit 3, Week 3. We had 4 big learning targets this week. First 2 are going to go super, super fast. Monday, the very first day, we learned that graphs of proportional relationships must go through 0, 0, and they must be a straight line. So the only way something can be proportional is if it starts at 0 and makes a straight line. This would be proportional. That's proportional. It doesn't matter the slant or how steep it is. It just matters that it's straight and starts at 0. An example of something not proportional, it could still start at 0 but be a curve. It could look like that. That is not proportional. It could be a straight line but not start at 0. We talked about that one day, kind of like the head start with the turtles, okay? So those are a couple of examples of proportional and non-proportional. All right, on learning target number 2, we had to identify graphs of proportional relationships, identify the constant on a graph of a proportional relationship. One big thing that we have talked about with proportional relationships is that the constant goes with the 1. So if you see 1, 4, the constant is 4. So looking at these 2 graphs, we had 2 ways to identify the constant from the graph. First, your work smarter, not harder way would be to find the 1 on the x. So if we're looking at this first graph, you're finding the 1 and you're going up, 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 up to where it touches the line and seeing if that is at a crisscross or a whole number. And in this case, it is. So your COP would be 8. The equation for that would be y equals 8x. Very simple. So that's the first way. Now, the second way is used mainly if we are looking at a graph and we do not have 1, the x value, touching at a whole number. So if we look right there, we don't know what number that is. It's hard to tell if it's exactly halfway or if it would be above or below. We just cannot be sure. So when you encounter something like that, that's when you are going to have to go up and find, you literally follow the line until you find where it touches a crisscross, and you're going to come to it right there. By crisscross, I mean where 2 of your x and y lines, whole numbers, come together, okay? A crisscross right there. So then you come down, you have to name the point first. So this point is 5, 35. It's really, really important to name the point because that's how you know which way to divide. So you're going to divide backwards. 35 divided by 5 equals 7. So your constant in this case would be 7. And then you can always go and double check the 1. Could that number be 7? Is 7 between 5 and 10? Yes. So it looks like our answer does make sense. All right, the next thing we did was interpreting points. I did not know that was there. It shouldn't be there. Interpreting points on a graph, okay? So this says that Leah makes wooden furniture for a living. Sorry, I keep having to do that. Let's see. Come on. Leah builds wooden furniture for a living. This is not doing what I want it to do. Okay, for some reason it's not letting me zoom in here, so I apologize for that. This says, Leah builds wooden furniture for a living. Her most popular product is a cedar porch spring. So she's building swings. The graph shows the proportional relationship between the time in days Leah spends making porch swings, X, and the number of swings she builds, Y. So it says, what does the point 8, 6 mean in context of this situation? Guys, all you have to know is how to look at a point and know which number goes with which axis. So 8, 6, the 8, you literally just come down. What is the 8 talking about? It's talking about days. So it means every 8 days, Leah builds. And then find your 6. What is your 6 talking about? It's talking about swings. So 6 swings. All right, the next thing is to write an equation to represent the relationship between the number of days D, Leah works, and the number of swings S that she builds. So replacing Y and X with D and S in context. So we know that our equations look like Y equals KX. So the first thing you're going to have to do is divide backwards, because the point that we don't have, if you find the 1, you can't know exactly what that number is because it doesn't touch a crisscross. So then that's where exactly what we just talked about in the last learning target, you have to write out the point, which is 8, 6 that was given to you, and divide backwards. So 6 divided by 8 is 0.75. So then our equation is Y equals 0.75x, but then they asked for D and S. So our Y-axis is up here, our X-axis is down here. So when we're trying to replace Y, that's talking about swings. So it would be swings equals 0.75, and then the X is talking about days. So the number of swings she makes is 0.75 times the number of days she is building, because that's the constant of proportionality. For every 1 day, she can build 0.75 swings. All right, and last thing here, we are looking at comparing proportional relationships. It looks like this might let me zoom in here. Comparing proportional relationships. The graph shows the amount of money raised during a school fundraiser by 3 different students. Who raised the most money? How do you know? So guys, the catchphrase of Wednesday's lesson was, the steeper the line, the higher the constant. So if we're talking about who's raising the most after a certain number of weeks, well, you can compare who raised the most each week. You've got a dot here, a dot here. It's easy to see that Han here has the most money raised at 1 week, okay? How do you know? You could either cite evidence that you know that at 1 week Han raised $100 and May and Claire had not raised $100, or you can say the line is steeper, so I know the constant, which means the COP is bigger, okay? And then it wants us to write an equation to represent the relationship between the number of weeks W and the amount raised R for Claire. Or sorry, not Claire, May. And I think actually, no, that'll work. All right, so let me delete that so that I can zoom back in here. All right, so in order to write an equation, in order to write an equation, we are going to have the constant of proportionality, okay? So if you look at May and you find the 1, and I go up, it's not touching a crisscross. I don't exactly know what that number is. It's below 50, so we know our constant has to be less than 50. So if you can't identify from the 1 what the constant is, then you have to, again, follow. It's that second learning target we talked about, until you find a crisscross. Some of them will look close, but that right there is the only one that is a true crisscross. So then our point there would be 10, 450. When you divide backwards, you get 45. Okay, so our equation is y equals 45x, and that would match up with this point right here. You can't tell what it is, but it's below 50, close to 50, but below, so that does make sense based on the rest of our graph. And then we just need to replace y and x. Okay, so the amount raised is r, and that is our y. So it would be r equals 45 times w. So the amount raised is 45 times the number of weeks she raises, because 1 week she raises $45.